Who's ready to do some math? Here we go. We're getting ready for our Chapter 2 test. You can see the learning targets here, and we are going to walk through them one by one. The first one, comparing. Comparing in math just means telling which one's bigger. So, as you probably learned when you were really young, that the alligator wants to eat the big number. What did we mean by that? We meant that there's like these big looking alligator mouths. We call them the greater than and less than sign. But really we call them the alligator, right? Eating the bigger number. And that still applies even in 8th grade. We're looking for the bigger number and we're going to have the alligator eat it. So when we have numbers that get tricky, and there are some that get tricky here, we need to kind of do the math parts to make it a more simple number before we compare. On the first one, it just kind of looks tricky because it's got a really long decimal, but we have two numbers that are exactly identical except one is negative and one is positive. Negative numbers are always smaller than positive numbers. So we know the alligator wants to eat the bigger one. It's going to eat 2.005. Now, technically, this says negative 2 and 5 thousandths is less than 2 and 5 thousandths. That's what that alligator mouth is actually telling you. On the next one with the sevens, here's an example of where we want to do the math parts as far as we can, because if it's not written as simply as it possibly could, we might miss something. So on the left-hand side, I see that I have a negative 7. A negative. Well, that's kind of like saying, I can't have no cake, or there ain't no presents, or I didn't steal nothing, right? So all of those things are double negatives. You might think I was just talking like a little kid, but no, they're saying double negatives. They're two negative things in a row, and technically what I'm saying is the opposite of what I said, what it sounded like I was saying. So if I said, I can't have no cake, I can't have no cake, which means I can have some cake. So all that tricky words is saying is that a negative number is really the same thing as a positive number. So if you see two negatives in a row, a minus, or a negative, that's really just saying positive. Think of it as kind of saying like the opposite of -7, which is 7. So two negatives make a positive. On the left, we have a 7. On the right, we have absolute value. Do you remember what I said about absolute value in car washes? It's kind of like that these two bars are like those squiggly things in the car wash, and your car has to drive through, right? And when your car drives through those lines, those car wash bars, those absolute value bars, it gets clean. And I think of negatives as bad things like dirt. And so I think of the negative as kind of like the dirt on the number. And when it goes through the car wash, the absolute value bars, it always comes out clean. It always comes out without the negative sign. So this would come out as 7. A lot of times people get it confused with an opposite. It never can be negative when it comes out. I think of it as absolutely always positive, the absolute value. So I did the math on the left, I did the math on the right, and it looks like I have the exact same number. Those are equal. All right, moving on to the next one. Here we go again. -4 is going through the car wash, and it's going to come out as 4. This other side is just -4/5. Well, here we have the situation like we did above. We have one number that's positive, one number that's negative. It doesn't matter what the fraction is, what the decimal, what anything is. If it's a positive and it's a negative, the positive number is always going to be bigger. The next one is a little tricky. See this car wash here? The dirt is hanging out waiting on the outside. It's kind of like somebody's ready to dump a bucket of mud on your car. Oh no, that's too bad, because when this comes out, it comes out a 9, but this negative is hanging out waiting, and it's going to stay on there. 0, don't be confused, 0 is right in between the positive and the negative numbers. So it is the very first positive number, and we've got 0 being bigger than negative 9. It is always going to be bigger than any negative number. Properties. Math properties are kind of like rules for what you can and can't do in math. These rules are kind of the most famous rules. So we've got the commutative property, meaning that the order of the numbers can change. I think about my commute to work is the same distance but a different direction than my commute home. So the order that you go in doesn't change. Now this has to apply only to problems with all addition signs or all multiplication signs. You might see it saying the commutative property of addition or the commutative property of multiplication. It's just saying that the order doesn't matter. The associative property is who I associate with. In other words, how do I group things? This is saying the grouping of the numbers doesn't matter. So how you group can move. So if this was one side, we'll say x plus y plus z, or x plus y plus z. See how I move the parentheses from here to here? So it's the same exact problem. It says x plus y plus z, but the place where the parentheses are is a different spot. I'm going to go ahead and match that here. Do you notice how these parentheses moved in the problem, but the problem still says 8 plus 2 plus 9, 8 plus 2 plus 9. So associative, the order is going to stay the same, but the parentheses will move. Commutative, the numbers themselves are going to move around. The order of the numbers is going to move around, and that one matches here. All right, the distributive property we're going to talk a lot about on our next slide. The distributive property is where I'm taking a number that's outside the parentheses, like 4, and I'm multiplying it times the numbers that are inside an expression. So let's say a plus b, for example. I'm going to distribute the 4 to the a and distribute the 4 to the b through multiplication. I thought of this problem, or the distributive property, as like distributing Halloween candy. So here I am standing at my door, and here are some kids that came with their costumes on, and I'm going to say, here's a candy for you, and here's a candy for you. It even works if there's 3 kids at the door. You can still use the distributive property, and here's a candy for you. So I noticed that this problem has the 4 being multiplied out times the 5, which is what made 20, and the 4 being multiplied times the positive 9, which made positive 36. We'll talk more about that on the next slide. Also, you're going to see that there's multiplication, even though you don't see the multiplication symbol there. There is multiplication, and addition or multiplication and subtraction in one problem together. The last property, the last popular property, there are several other math properties, is the identity property. Identity property means the identity of the number, what the number is, will not change. So to keep the number the same, you could add 0. To keep the number the same, you could subtract 0. To keep the number the same, you could multiply times 1 or divide by 1. And you notice that up here, the identity property is happening when we add 0. See how the negative 15 is what we start with? We add 0 to it, and we end with negative 15. The identity, the number itself, didn't change. The distributive property. I probably like this property way more than I should, but I love this property. So we're going to apply the distributive property. This is one that we can use a lot, and it's very helpful when we have variables. Because as you can see, for all of these problems, I can't actually do the math that's inside of the parentheses because there's variables and they're not like terms. So what we need to know before we start is when you have a number next to a parenthesis, for example, 5 is next to a parentheses with like 6 inside. That's saying 5 times 6. If I have 3x, that's saying 3 times x. If I say 4 and then I have 1 plus 2, I'm saying that's 4 times 1 plus 2, or 4 times 1 and 4 times 2 added together. So that's what I'm going to do. I'm going to do this last thing. I'm going to distribute the number that's outside the parentheses to both of the two things inside the parentheses. Now let's go back to that 4 times 1 plus 2. If I were doing that problem with order of operations, and I'd say 1 plus 2 is 3 and 4 times 3 is 12. Okay, that worked, right? If I take 4 times 1, I got 4, and 4 times 2, I got 8, and since it's a positive, I'm going to write plus 8, I get 12. So the distributive property is saying it doesn't matter which way you do it. If you do it this first way or the second way, you're going to get 12 regardless. So I am allowed to take this number set, and I can, instead of doing the parentheses first, I can distribute across. So I'm going to take my -3, always take the sign of the number that's in front of it and apply it to that number. So my -3 times +9 is -27. If I'm multiplying and there's a variable, as long as there's only one variable, I can just tag it on to the end. If there were two variables, I would have to multiply those two variables, either including both or making it squared. We haven't done a lot with that yet. It will still be coming. So the problems you see on this page are similar in nature to the ones that you're going to see on the test. So you don't have to worry about when do I multiply variables. We're not really at that point yet. So then I'm going to take my -3 and times it by the 4. But I need to look at this sign in front to know that it is a +4. So -3 times +4 is -12. Now -12 looks now like I said -12, doesn't it? I did. Okay, I said -12. I also said -12. It's the same thing. So we're starting to get used to a negative and a minus being the same thing. It actually means the same thing. Let's move on. So the second one, we have 7 outside of b minus 6. So I'm going to go ahead and distribute the 7 to the b and the -6. So 7 times b is 7b. And 7 times -6, remember the negative's important, is -42. So now it looks like 7b minus 42, and that's what it is. Moving on. -2 times 5a is -10a. -2 times +1 is -2. And the last one, 6 times 5g is -30g. 6 times +8 is +48. If for some reason I was able to combine like terms on these, I could. On your test, you're going to have small ones just like this. In your future someday, there will be bigger ones that might end up having like terms that we can combine in the end. We don't have to worry about those for this chapter. Okay, before we move on to the next learning target, which is I can add and subtract expressions, we have to know how to combine like terms. We're going to spend just a brief moment on like terms. So terms are these things. They're the parts in an expression that are separated by plus and minus signs. Okay, so those are my terms, and these are my terms. I'm including this because we want to treat that as a negative. I should include this too. Okay, so I'm going to take the terms. I'm going to look for ones that are alike. Like terms mean that they have the exact same variable part. So if they both have z, for example, 4z plus 5z, I could put those together because their z is the same. Think of it like anything you could name, like 4 zebras and 5 zebras make 9 zebras, right? But if I have 4z plus 5c, and I say 4 zebras plus 5 camels does not equal zebras and does not equal camels, right? We can't put those numbers together and call them either Z's or C's because they're not. We could call them animals, but that's not really the point of this. So Z and C can't go together because they're not like terms. If I have the same letter, but it's to a different exponent. So for example, if I have 3x squared plus 2x, like that. They both have x's. So I've got 3 xylophones squared plus 2 xylophones. Well, that's actually different. So in class, we talked about the difference of PlayStations. We said a PlayStation 2 is different than a PlayStation 3. So if I have 5 split PlayStation 2s plus 2 PlayStation 3s, I can't actually put them together and call them all PlayStations, right? Can't call them all PlayStation 2s. I can't call them all PlayStation 3s. They are actually different things. So they have to be exactly the same variable for us to add them together. Now that we know that, let's look through these problems. I have a 3g, a 2g, a minus negative 8m, and a 5. Okay? I notice that these two parts have the same variable part, so I can put them together. 3g's and 2g's make 5g's. We could think of it as 3 giraffes plus 2 giraffes together makes 5 giraffes. Now the rest of this I can't do anything with. I could make this simpler by saying instead of minus 8m, I could say plus 8m plus 5. On your test, you're not going to have anything like this where you need to simplify that in combining your like terms. It'll already be a part of it. Okay, that's as simple as I can make this one because G, M, and we call this a constant when it doesn't have any variable part. They're all different, so they can't be put together. Let's look at the next one. The next one I have Y, T, T, and Y. I could put my Y's together and I could put my T's together. So I've got a negative 6y and a positive 8y. So I'm looking at negative 6 and 8, and I'm adding those together to get 2y. Then I've got positive 4t and negative 3t. Put those together, and I have 1t. Now, technically, that's not as simple as I could make it because I can take 2y plus just a t. That's the same thing as saying 1t, and we want to make it as simple as we can. All right, so we needed to know that in order to add and subtract. When you are adding, I'm going to do the adding one first. When you're adding expressions, you need to look at it as all the like terms. So I've got 9x, positive 2y, negative 5x, and positive 7y. So those are my terms. Since we're adding, we can just put those terms together. So let's go ahead and do that. We've got 9x and negative 5x, which shakes out to be 4x, 2y and 7y, which shakes out to be 9y. It doesn't matter which one of these I put first because they're to the same power. If they were to different powers, I would put the one with the highest power first. It's not technically wrong to put it out of order. It's just kind of like the custom of how you do it. All right, let's do my other addition problem next. So on this one, I've got negative 11b, negative 4, 5, and negative b. So I'm going to put my b's together. I've got negative 11b, and if it doesn't say anything, it's 1b. So negative 11 plus negative 1 is negative 12b. And then I have negative 4 and 5. Those are both constants. They can be added together. So negative 4, put it together with 5 is a positive 1. Now for this one, you would want to start with the part that has a variable and do the constant at the end. Again, I'm not going to mark it wrong if your order is wrong, unless your negatives are wrong. But to know that is important, because that's how your answer key will always look. And so when I'm putting answers on the board, your answers will always match if you put them in the same order that I do. All right, now we have to talk about subtraction problems. If there's a subtraction sign here, it's saying that it is going to subtract this entire group, okay? So instead of just keeping that minus with the negative 4, we're going to put the minus sign with all of it. So we're going to basically take this and distribute it across the parentheses. So I'm going to go ahead and change this to a plus. When I change it to a plus, I'm changing everything that comes after it to its opposite. So the opposite of 4 is negative 4, and the opposite of 8 is negative 8. So now my new terms, these ones didn't change, are negative 4x and negative 8y. I'm going to put them together with their partners here. I've got 3x and negative 4x, which makes negative 1x, which I can write as just negative x. And I've got 5y and negative 8y, which shakes out to be negative 3y. Again, the order doesn't really matter on this one because it's the same power. Let's do the last subtraction problem. So here I'm going to change my minus to a plus. And remember, it was subtracting everything that was in here. So everything that I just changed from minus to plus, I need to change to its opposite. So the opposite of negative 9 is positive 9. The opposite of positive 10c is negative 10c. I can combine my 4c with my negative 10c, and I get negative 6c. I can combine my negative 2a with my positive 9a, and I'm going to get plus 7a, or positive 7a. So if I ever end up with a positive number, I will use plus. If I end up with a negative number, I'm just going to write negative whatever it is, and it will look like minus, because that's what we're doing. We're almost done. The last one. This one is multiplication and division. So when we multiply, we actually have done all of this already. We're just shoving things together. So here you see I've got a multiplication problem happening because there is no symbol in there. So there's the distributive property that needs to happen before I can add and subtract all these parts. So I'm going to go ahead and rewrite this back part as 5x minus 5y. It's minus because this is kind of like a negative 1y. Then this beginning part doesn't need to change at all. Okay, so I'm going to look for like terms. I've got 2x and 5x to make 7x, and 8y and negative 5y to make 3y. And then this negative 4 can't go with anything else, so we'll just tag it on the end. Let's do it again. So again, we're just doing things we already know how to do, but putting them all together at the end. So I've got 2 times 3c, but notice that it is not a normal 2, it's saying minus 2. So we're going to apply that as a negative 2 times 3c. So we've got 3c, and then since it's negative 2 times 3c, it's a negative 6c. So I'm going to write negative 6c, which looks like minus 6c, which is what it really is. And negative 2 times 4 is negative 8. I can put my 3c and my negative 6c together to make negative 3c minus 8. Done. I put one extra division problem in here just to show. So when we're doing division and there's a variable, we can't do all of the top part first, but we can take each separate piece and divide them. So this is saying this whole thing on top is being divided by the bottom part. So I can take it separately. I can take 8d divided by 8. So I'm taking the number parts. 8 divided by 8 is 1. 1d. In other words, d. Okay? And then I'm going to take this other side, 32, and I'm noticing it's a positive 32. So positive 32 divided by 8 is 4. A positive 4. And that looks much simpler than what we started with. We're going to do it again. So I've got 15 divided by 3, which is 5, and negative 21x divided by 3, which is negative 7x. And the last one, I've got negative 20w divided by 4, which is negative 5w, and positive 4 divided by 4, which is 1. Done. Thank you so much for sticking to the end. This was a super long video. Other things you can do, go over your notes, look over past assignments, practice IXL. There's review videos on there that might be shorter than mine. Or try a study party with your friends or even your mom. Thanks, moms, for listening. Have a great night, and dads too. Have a great night.